Hello students, today we will discuss simple correlation. First, the meaning of correlation. This is relationship between two quantitative variables without being able to infer causal relationships. So correlation is a statistical technique used to determine the degree to which two variables are related. We can represent correlation with the use of scatter diagram. We represent both variables on x-axis and y-axis. So scatter diagram can be of type rectangular coordinate, two quantitative variables. One variable is called independent, this is denoted by x, and second variable is called dependent variable, this is called y. So these points are plots. This is scatter diagram, so points are not joined. So there is no frequency table, only we have two variables, values of x variable and values of y variable. There is example. In first row, it denotes weight in kilograms, then SBP, uh, first variable denoted by X and second variable denoted by Y. We plot these variables in this diagram. This is a two-dimensional diagram. In x-axis, in horizontal line, it is denoted weight, and on y-axis, this is SBP, systolic blood pressure. So we are to find the association between weight and systolic blood pressure, whether these variables are correlated or not correlated. We can find the correlation between these variables by using this scatter diagram method. So scatter diagram of weight and systolic blood pressure, we draw imagined line which is covered or more close to maximum number of points, and we can find the association whether there is positive relationship or a negative relationship, as slope of this line is positive, so there is positive relationship between weight and systolic blood pressure as shown by this scatter diagram. So scatter plots. So the pattern of data is indicative of the type of relationship between two variables. This is can be positive relationship as we seen in the last example. There can be negative relationship. There can be no relationship. Now this is another example of positive relationship. All points need not to be in a straight line, but these are very close to a positively sloped line. So in x-axis, there is number of hours spent studying, and on y-axis, this is final grade in course. So these are positively associated. Then this is the diagram. This is age in weeks and height in centimeters. As we know, we plot these points. Then this is a negative relationship diagram, age of car and reliability. We see the points moving downwards from left to right, negatively sloped. And here we can't conclude anything, can't conclude as all points are scattered. There is one on x-axis there is pulse rate, and y-axis there is weight. There is no association between pulse rate and weight as shown by diagram. Now we discuss correlation coefficient. So the statistic which show the degree of relationship between two variables is known as correlation coefficient. Then simple correlation coefficient denoted by small r. It can be Karl Pearson's coefficient of correlation or product moment correlation coefficient. It measures nature and strength between two variables in quantitative. Sign R, it denotes the nature of association, and its value denotes the strength of association. If the sign is positive, there is a positive relationship, and if the sign is negative, there is a negative relationship. So value of R lies between -1 and +1. If R is 0, it means there is no association between the two variables. If value of R lies between 0 to 0.25, this is weak correlation. If it is from 0.25 to 0.75, it is intermediate correlation or moderate correlation. If it lies between 0.75 to 1, this is strong correlation. If it is 1, this is perfect correlation. Then one thing more, this is absolute value of R when we ignore the sign. Now this is the Carl-Pearson's method of correlation to calculate simple correlation. This is an example. We have two variables x and y, anxiety and test score. We calculate these calculations. We put the values and we find R is equal to minus 0.94. So there is negative and high degree negative correlation between these two variables. So this is indirect strong correlation.